Hello world, my name is Michael. Unit testing. It's one of those things we all say we do, but not everybody does properly. Every developer has heard what makes unit tests good, but few ever stop to think about what makes them terrible. One of the things we do here at Janksters whenever we start a new project with an existing code base is to audit the tests. Some are great, some need work. Since everybody and their mother claims they know what makes tests great, we thought we'd take a look at what makes them bad. With that in mind, here are 5 signs your tests are terrible. Quick disclaimer, we are mostly going to be talking about unit tests today. Integration tests are a whole other beast and best left for another video. Let's get on with it. Number 5, they are useless. Calm down, put down the pitchforks. I'm not saying all unit tests are useless. I'm saying that if your tests don't even do what you want them to do, then what's the point of having them? Useless tests, like ice cream, come in all sorts of flavors. A few examples will be tests that test external services, tests that reproduce the implementation of the unit they are supposed to be testing, tests that do not actually test any meaningful cases of the business logic. The list goes on. A lot of this is due to the pursuit of 100% test coverage, and I'm just going to go right out and say it. 100% test coverage is a dangerous myth. In my view, not everything needs a unit test, and some things just flat out can't be tested. Think main functions in Go. So, if a test exists solely to increase the coverage but doesn't test functionality, it has no business being in your test suite. If you use an external library, then you shouldn't be testing it. It's not your job. It's the package maintainer's job. If you don't trust that the library works, then you probably shouldn't be using it. Number 4, they lie. Unit tests can act as documentation, enforcing the contract of the units they test. But what happens when they lie? Since I love my contrived examples, here's a simple case. The eagle-eyed among you have already seen the bug, but that's not the point of this example. The point is that the test passes, but is it telling us the truth? Does our function work? We could say this is a function problem and that the function is badly written, but isn't that what tests are supposed to catch? The fact remains that the test is lying to us. It's giving us a false sense of security that our function is working. It's lying by omission. Another example is if our function throws an exception and the test silently ignores it. In this case, the exception is part of the function, and silently ignoring it and acting as if everything is fine is just wrong. Regardless of how unit tests are lying, whether they are just wrong or lying by omission, if they are lying, they are bad. Number 3, they are slow. Do you know what happens to very slow tests? They do not get run. If your test suite takes 30 minutes to run, then your developers are not going to run them while developing. Well, this is strictly not true since most test frameworks allow you to run individual tests. But the fact remains that slow tests will slow down the developer feedback loop. Even worse, slow tests can be very expensive. Here's a simple case. Imagine a test suite that takes 30 minutes to fully complete. That means for each feature a developer writes, you have to tack on 30 minutes to the development time just to see if the new feature doesn't break anything. If it does, then you are adding a couple of hours. When that feature goes into the CI/CD pipeline, each build there is going to be at least 30 minutes, even if we assume all the other processes are instantaneous. Now throw in 20 developers working on that same code base. That's 10 hours of build time if every developer pushes a feature. If your CI/CD uses build hours for billing, you're going to run out of those very fast. If it doesn't offer concurrent builds or has limited concurrent slots, then there's going to be a build queue a mile long. If it has unlimited concurrent slots, you're going to be paying out of the nose for each long build. Even worse, that slow pipeline is going to affect how often you can release features. No doubt about it, slow tests are a lose-lose. Number 2, they are greedy. Greed is an excessive, extreme desire for something, often more than one's proper share. Greedy tests want everything. For example, super large tests that test multiple things are greedy. or tests that have logic in them, or even worse, tests that do both. If your tests want to do everything and be everything all at once, then they are bad, greedy tests. Here's a couple of questions you can ask to help you see if your tests are greedy. Can you succinctly describe what is being tested in one short sentence? If no, it's greedy. Do you have to use the conjunctions and or in the description to add clauses to the description? If you do, they're greedy. Do you use an if statement in the test code? If the answer is yes, the test is greedy. Now, why are long overthinking tests bad? Well, because they're hard to work with. If you have 20 assertions in one test, you're going to have a bad time. If you don't want to have a bad time, then make sure your tests are short and test at most one functionality. This is not to say only one assertion, although some people advocate for that, but one functionality. For example, if you are testing a function that logs in a user, instead of one giant test that tests everything, it would be better to break it up into smaller several tests. For example, one that tests the happy path, one that tests bad password, one for exceptions, etc. This makes it easy to quickly find out what's failing, rather than having to wade through one super large test. Number 1, they're flaky. Determinism is a funny philosophical word with a long rambling definition that can be boiled down to current effects are entirely determined by previous existing causes. Good tests, and functions for that matter, are deterministic. In other words, given the same input, they will run exactly the same every single time. So, what happens when they don't? Well, then they're flaky. A flaky test is one that intermittently fails for no apparent reason or works on some machines but not others. A lot of things cause flaky tests. A few of the most common ones include poorly written tests, race conditions, run order, external dependencies, inconsistencies in the test environment, or even bad units that they are trying to test. How does flakiness hurt? First, it slows down development. For example, if you have a flaky test in your CI/CD pipeline, then it will fail at random times and slow down everything. They also reduce trust in your tests and trust in the implementation, since something might be seriously wrong with the actual business logic. They introduce extra effort in debugging and increase maintenance expenses. So, flakiness is bad. If flakiness is not for you, then there are ways to reduce the risk. For example, you can make sure your tests are isolated properly and truly independent. This reduces incidents of tests conflicting with each other. You can introduce proper data management structures that ensure that test data is neither mutable nor shared. You do not want one test influencing how another runs. You should also continue to monitor your test, and flakiness should be reported and addressed as a matter of urgency. You can also implement test retry mechanism, basically rerunning your failed tests. This, though, is a double-edged sword, and you don't want to just automatically rerun tests in place of actually fixing them. That would be a fate worse than flakiness. And that's our list. There's a lot more we can talk about flaky tests and pretty much everything we talked about today. But if we did that now, we'd be here all day. So we'll save that for future videos. But in the meantime, we'd love to hear from you. What are some things that make tests terrible for you? Tell us about them in the comments. Don't forget to like and subscribe. And as always, happy coding.